Today we made our 3D models, right? And I have mine up here to show you. We saved yours, so if you need it at any point during today, we can get them out and you can, touch them and use them in whatever way is helpful. But I also want to, show you this so you can get an idea of what we're going to see like more on paper, like what the three-dimensional display is going to look like on paper. Okay, and I'll compare this video to what we made. Okay.
The distance measured from the origin along the x-axis along the direction shown is taken as positive. The distance measured from the origin in the opposite side is considered negative. To indicate this, we assign the symbol x dash. A similar convention is followed for calculating the distances along the y and z axis.
So mine up here, my pointy ends are towards the positive, and the blunt ends are towards the negative.
The plane formed by the x and y axis is called the xy plane.
So that's our yellow piece of paper.
Similarly, the plane formed by the y and z axis is called the yz plane.
Pink.
And the plane formed by the z and x axis is called the zx plane.
Oh, whoops, that was blue, and then this is pink.
The xy plane, yz plane, and zx plane divide space into 8 octants. Here, x or yz is an octant.
Okay, so
This
with
octant
it,
is
hey,
enclosed by
I
the
said pause.
xyz axis.
Okay, so as we said yesterday, octants 1, 2, 3, and 4, and then we come below 5, 6, 7, and 8. Okay, those of us who couldn't be here today, they at least have that video that they can rewatch if they need to. Okay, so the two things we are going to do today, only two, we're going to talk about how to plot points, and then we're going to talk about how to find the distance between 2 points in 3 dimensions. Okay? I will expect that you tell me where the point is. So if the point is lying on an axis, you would tell me which axis. If a point is lying in a plane, you would tell me which plane. If a point is lying in an octant, you would tell me which octant. Okay? Now, graphing in 3 dimensions on a 2-dimensional piece of paper is a little bit strange. So what I'm going to do is I'm going to hand out graph paper that looks like this. Okay? And what you can do, there's enough room on here to where you can use it for notes and you can use it for your homework. So please do not draw a giant X, Y, and Z axis on here. We're going to make small ones. We're not going to move very far. We're going to make small ones. So when I, don't draw anything on this yet, please. The chances are very small that is your job. So the whole bring a bunch of plastic
I totally
went right through the
thought, no, actually this morning, driving to school, I was like, that's really great, but then we maxed out deadlift, and now it's like,
okay, so we're going to move a maximum of 4 away from the origin. So we don't need this to be very big. But what you're going to do, your x-axis, so your z-axis is going to be the one that's straight up and down. Okay. Your x-axis is going to come out towards you, and it's kind of at an angle so that we can get this all in. And the y-axis is going to come out towards the right. So x, y, z. I would put it in like the top left corner so that you can draw another one when we do some more examples, and then another one when you do your homework. I know, it takes a little bit of getting used to with your eyes. Okay. That is the point.
Had this notebook since 5th grade.
Okay, does anyone need more time to draw their 3 space?
Yes.
Okay.
I'm sorry.
No, I'm not nervous. I was really
Okay, so then take one of these lines, like take this line and trace it.
Exactly. Have you seen mine?
Oh, so it's my line too small.
Oh, you'll be great. But now you need a y-axis.
And then this
Pieces there. And it's a room, a chair, a bowl of water, a goldfish, and a knife and fork. And a knife small. What if someone just grabbed a knife and started going inside? You can't. It's roped off.
Okay,
Oh, yeah,
so you kind of have 3 lines drawn that intersect. Okay, please make sure your X, Y, Z are labeled like mine are. And I labeled them on the positive end. Okay. Okay, so the point 3, 0, 0, I am going to plot in red. So X, Y, Z, 3, 0, 0. We are going to move 3 along the x-axis, and that's it. So since this lies on an axis, then we would say that it's on the x-axis.
So how, when you count 3, is it the bottom of the triangle?
This is the origin right here where all 3 axes intersect. Okay. In green, we are going to plot the point 4, 0, 4. Okay. Okay. So anytime we move in the Z direction, we're going to leave a little breadcrumb trail so that we can visualize what's happening. So 4, 0, 4, we're going to move out 4 on the x-axis. We don't move anything out on the y-axis. And then we're going to move down 1, 2, 3, 4.
I thought
Why
that was
are
the
they going
negative
down?
direction.
Oh, that is the negative direction. It is a positive 4. So 1, 2, 3, 4. If I don't leave that breadcrumb trail, you would think that it was on the negative side of the y-axis. You see what I mean?
Yeah.
Okay.
It's on the ZX.
What do you say?
So it's on the ZX plane.
Okay. It is in the XZ plane because we don't have a y coordinate, right? It's sitting in that piece of paper that we could make out of the X and Z axis. Okay. All right. Now, let's get some coordinates where we get to move in all 3 directions. Are you ready?
Yes.
Okay. So I am going to create a new 3 space. It's up to you whether you want to keep them in the same 3 space or if you want to draw a new one. All right, so 2, -3, 5 is the first coordinate we're going to plot on this page. What I want you to do is I want you to create a parallelogram out of the x, y coordinate and then breadcrumb trail up or down for z. So Here is 2 in the positive x direction and 1, 2, 3 in the negative y direction. So what I'm going to do is I'm going to create a parallelogram of breadcrumbs, if you will. And then from 2, negative 3, I'm going to move up 5. Hi, Brayden.
Hello.
Who-
We just got
who is she?
Miss Isis.
Oh, yeah.
I'm sorry.
Oh, I bet with that he said tennis.
Okay,
I was like,
let me
you
get
thought you
this
did one?
to Brayden and then. Okay, so this is 1, 2 on the positive x-axis. And then I went 1, 2, 3 in the negative direction on the y-axis. And I made a parallelogram. Okay, so this right here, Riley, would be the point 2, negative 3. And from 2, negative 3, we counted up 5 in the z direction.
Well, I don't have enough room.
Oh,
So that's a problem. We'll just go with 4.
you can create your own example and just change the z. Try that again. Okay, Dallas says octant 4. Do you agree?
Yes.
Okay. We went positive x, negative y, and up 5. So we're floating right here in 1, 2, 3, 4. Okay. If you need this in your hands to figure that out, I have no problem with that. Okay, that's why we made the next one. Okay. All right, so then negative 2, 6, 2. Let's do that one. I'll do that in green. So negative 2 on the x-axis would be back here. And then 6 on the y-axis would be 1, 2, 3, 4, 5, 6 right here. Okay, so I am going to create a parallelogram with negative 2x, positive 6y, and then from the corner of that parallelogram, we will lift it up 2. Consult your neighbor, which octant do you think that lives in? Monique, which octant?
2.
Octant 2. Do you agree with Monique? Octant 2. Okay, we went negative x, so we went behind and over and then up. So we're sitting right here. Great. Okay. So part of, I definitely did clean that wrong. There, like this. Part of your assignment will be to name a point. Part of your assignment will be to plot a point, and either way, you're going to need to tell me the axis, the plane, or the octant in which it lies. Okay? That will be a part of your test. Also, name a point, plot a point. Name a point, plot a point. Okay? All right. The distance formula for 3 space looks pretty similar to the distance formula in 2 dimensions, doesn't it? All we have to tack on is this z minus z squared right here. It's the exact same formula with just a 3rd dimension. Do you have it written down? One example? And then we'll do a little, no example, says Dallas.
That wasn't me. I was laughing.
Oh, see, guy sits behind you and he like projected his voice through you.
I projected.
Okay, write down these two coordinates. We're gonna find the distance.
My bad.
It does not matter which coordinate you choose as the first and which coordinate you choose as the second, because we're subtracting the two and then squaring them. So they're always going to have a positive number under that radical. Okay? So the distance between 419 and 216, which both lie in which octant? The first octant. When all x, y, and z are positive, we're in octant number 1. So we are going to have x minus x, the quantity squared, plus y minus y, the quantity squared, plus z minus z, the quantity squared. Okay. All right, 4 minus 2, the quantity squared. 1 minus 1, the quantity squared.
0.
9 minus 6, the quantity squared. So our distance is radical 13, and that's how I want you to leave it. If it's a radical that can be reduced, please reduce it, but please leave it in radical form. That, ladies and gentlemen, concludes our notes for today. I do want to do one thing before I send you on your way to your homework, though, okay? Let me just finish.